Previous class I was discussing about relation algebra operations, right? I discussed about how the relation algebra works with the DBMS, and DBMS, right? So it's one of the query language where it works with the symbols, various symbols that can be utilized for retrieving a queries, right? So now let's start with the way of what we started, and then I will go with the flow of coming with the natural joins with the join operation that specified, so that the algebra with specified symbol work well for retrieval queries using DBMS. Okay, we discuss about selection symbol, right? We discuss about selecting conditional attributes in a table. Then we comes up with a pi symbol, or projection symbol that speaks about. It speaks about a projection symbol, right? So retrieving a attributes, not a condition attributes, retrieving a attributes, right? For example, I want to retrieve the employee table SSN with the department number. Then I can utilize that. The projection symbol can be utilized well. Projection symbol can be utilized well, right? So then I have comes up with union operation. So we discussed about how the union operation works in the last class, right? I told specifying the female employees with the dependence table, how can you join these two tables, or how can you utilize this union, these two tables for retrieving the effective data based on the condition provided, right? That is applied through union. So I take an example also teacher and students, right? So I taken two tables, the first name and last name age for teacher, and for students again I taken with teacher with the first name and last name, for students with the first name and last name and age that has been come up, right? So union, intersection, minus. Okay. Then we discuss about Cartesian product. Then we discuss about an Cartesian product, right? So these are the things, symbols have been discussed in a previous class regarding a relation algebra with an DBMS. So now I'll move to joins. So joins. So one of the most important operation in a relation algebra is joins. Without joins, we're not able to effect a retrieval between the tables. For effective retrieval, you require joins. Okay. The first one comes with natural join. First one comes with natural join. Okay. So natural join is nothing but multiplication we call as. The star symbol that represent a natural join. Okay. The first table I want to go with natural join example is because whenever I talk about DBMS, it's examples. Because we want to, whenever I think about DBMS, it's examples. Without example, I'm not able to deliver a best lecture in DBMS, right? So because example plays main role in DBMS. That two real-time example plays a main role in DBMS. Okay, that's what natural join. I will go with example so that the definition what it provides is very easy to understand. The first one goes with, I'll go with the department table. And I will go with project table. Okay. So department as I told, there is a department number, there is a department name. Okay. Then I may think about SSN. Here I go with P number, P name, and D number. So 10, 20, 30. So research, library, sports. So 1, 1, 2. Okay, this is a foreign key because project as a table. There's no, because when I go for natural logic, there's not specifying the foreign keys. I'll specify only the primary keys. So project has P number as a primary key. Department has D number as a primary key. So write 3 departments, department name, ISC, CSE, EC. Let's go with one circuit branches. So 111 is the manager of this department, 222 and 11 again. So I'll make it as a, repeat the process because it's SSN as an attribute that refers. Okay. So now I will write project stars department. So project multiplication or a stars with department. Okay. So here when I tell us that when I go for natural join, natural joins by simple way like this. So R contains let's attribute like x1, x2, x3, y1, y2 and y3. Okay. So R is a relation containing attributes like x1, x2, y1, y2 and y3, where S is another relation containing y1, y2, y3, while z1, z2, z3. Okay. So S is a relation that contain y1, y2, y3 and y continuation with other attributes, that is x1, x2, x3. So there is a relation, two relation with the attributes like x1, y1 and z1, right? So my job is to do natural join between these two attributes. So first natural join is things is that when you go for thinking the two relation with R and S with the attributes, when it talks about natural join, it is going to join these two tables using common attribute. Okay. This is not required foreign key. It joins works with a common attribute. So here we have a R with the X attributes and Y attributes, S with the Y attributes and Z attributes. Okay. I will join or natural join was between two relations with the attributes with the common attributes. So R has x1, x2, x3 and y1, y2, y3. S has y1, y2, y3 and z1, z2, z3. This two join can be, this natural join works on this two relation with a common attribute called y. Okay, this makes natural join. Okay, when I talks about R natural join with us, so both the table will work with the natural join using common attribute. So here x1, x2, x3, y1, y2, y3. So here y1, y2, y3, z1, z2, z3. So when I tell natural join, y1, y2, y3 joins with relation of S with the y1, y2 and y3. Okay. So this is the way the natural join works. Like. Okay. So now department goes with a project. So I'll turn project natural joins with department. So project natural joins with department. Okay. So what I want to do, so I have two tables, right? I have given example of department number, department name, SSN, P number, P name and department number. Okay. So now as I told, it works with a common attribute between the two relation. That is, project as a D number comes with a department D number. So this D number is a common attribute between project and department. So D number is a common attribute between project and department. Based on D number, I need to join two tables. That is department and project. Okay. So if I write like this, so it has P number, P name, D number, D name and SSN that comes with, right? Then comes with. Okay, so P number, so it has 10, research, department number 1, ISC 111, right? It's for natural joint works, right? It's working beautifully, right? So 20, library 1, ISC 1111, right? So 30, sports, okay, 2, CSE with 2, 2, 2. This is a table I have been built using natural join, using natural join, right? Now, what is the drawback of natural join? It works well with join these two tables using common attribute called department number, right? So my question is, what may be the drawback of natural join when you're thinking about common attribute between two tables, between the two tables? So what is the drawback, right? My question is, what may be the drawback? What may be the drawback? So now, if I tell, like I told, D number is a common attribute, instead of that, I may think of changing tables called employee with the department, employee with the department, okay, employee with the department, because I want to search a common attribute, what I call as drawbacks in natural join, drawbacks in natural join. So if I consider your employee, so employee comes with the SSN, name, and age, So departments comes with D number, D name, age, right? So now, what is the common attribute? So I have two tables, employee, natural joins with department, employee, natural joins with department. So what it happens now? When I'm going for common attribute, there is a age between employee and a department, right? Age is a common attribute that's placing role between in employee table age and department table age. So if I based on age, can it possible to join these two tables? If I consider age as a attribute to join between two tables, what can you imagine the duplication attribute that arises? Because here I am joining using primary key. Here I made a natural join of common attribute using department D number primary key. But here I am not going a foreign key with the primary key reference. I am going to join this two table with the two table using common attribute. So employees age, we have almost in MIT, we have almost 250 to 350 employees we have here. So almost about 200 people teaching, and with 100 people about non-teaching, about 300 faculties with non-teaching are available. Based on age, can it possible to join between the tables? Because age is an attribute which contains most repeated items. So if consider age, it may be 24, it may be 24 again, right? Here, for 24, join with this. How many 24s are available in the entire 300 tuples, right? So it's getting huge. So duplication content is getting huge when you go with a common attribute. Because age is repeated. So consider we have almost 300 employees. So name of 300 employees with the SSN of unique ID, the primary key, then I go in the age. So most of the employees are hang. So between 25 to 40, you can have n numbers of employees in 300 tuples. 300 tuples who are belong to age between 25 to 40. There may be repeated and join all these tables with a join as a what you call age as a common attribute. There is a 24 goes with the age of 24. So there may be 24 repeatants. So then I can 24 joins with 24, 24 joins with 24, 24 joins with 24, right? Because age is a common attribute. It's not a primary key or a foreign key. But while I was doing project with the department, I joined two tables using common attribute called department number. Works well because department number is a primary key. When you join the two tables without primary key or a foreign key, people are having huge table with a duplication. Huge tables with a duplication. The duplication makes it DBMS worst. Makes DBMS is a worst possibility. Okay. So this is the one way of problem in natural join. This is the problem in natural join. So always join two table using primary key and foreign key instead of common attribute. Instead of an common attribute. That is called natural join. That is called an natural join. Hope I made it to understand how the natural join works. How the natural join works, right? So this is the beauty of natural join. Okay, hope it's one of the important question in your exam perspective. In your exam perspective. Okay, when you go for exam, they may ask to explain the types of joins, or they may ask you what is natural join. Give an example and discuss the drawbacks of natural join. So what is natural join? So join between two relation with x and y with a z with a common attribute, it joins. So given example is given. Then if I go for drawbacks, when you go for common attribute, you can find a huge duplicated tuples in a table that is done through natural join using common attribute, that is like age. So I'm try to join two tables with a common attribute, that's the employee age and department age. So if we're going to join these two tables, duplication arises. As I told, example of 300 employees, age may be repeated items, contain repeated items. When going to join this, it become most duplicated. It become most duplicated. Okay. So this is about natural join that it contains. Natural join comes with the DBMS. So then I'll go with Theta Join. So Theta Join. So Theta Join. So this is the symbol that represents Theta Join. So Theta Join, as I told again, it works between two relations with using Cartesian product, represented through various symbols that represents this Theta Join. Okay. So R is a relation, Cartesian product with S. So R is a relation and S relation. We're going to do Cartesian product. So already I told about Cartesian product, right? So R is a relation, S is a relation, X is an attribute of R. X is an attribute of R. Okay, X is an attribute of R. Theta, it comes with a theta. So two attributes coming with a theta. So X is an attribute of R and Y is an attribute of S. So R is a relation, S is a relation, doing Cartesian product. What an attributes of, that is X comes with a R and Y comes with a S. This is theta. So the theta works between two attributes with the Cartesian product. Okay. So this theta can be equals. So two attributes can be equal. As I told, this department table can be equal to project table with a D number. So department D number is equal to project D number. That is equals. Using equals, it may be equal, right? Right? So then it may be less than, equal to, maybe the two attributes may be less than or greater than when you think about salary, right? So greater than, equal to, okay, not equal to. So R is an relation, S is an relation, X is an attribute of R, Y is an attribute of S. The X attribute, this going to theta between X and Y, the theta can be equal. theta can be equal, right? Theta can be equal or less than equal to or greater than equal to, or it may be not equal to. Okay, these are the operations that can be applied between two attributes specified by a relation called R and S. R and S. Okay, this is theta join. This is an theta join. This is an theta join, or it may be less than equal to, or it may be greater than, or greater than, or a less than, greater than, or a less than. Okay. So this is what theta generation, theta join works like. So R is a relation, S is a relation, X is an attribute of R, Y is an attribute of S. So then there may be equal, there may be greater than equal, there may be greater less than equal, there may be not equal, there may be only greater than, may be less than. Okay. But when theta join is equal, when theta join is equal, when theta join become equal, it's called equijoin. It's called equijoin. It's called equijoin, represented like this, represented like this, represented like this, represented like this. So what is equijoin? When theta join, theta with R and S relation, or S comes with the attribute X and Y. So when the theta here between the attributes of X and Y become equals, that is called equijoin. That is called equijoin, represented like this, represented like this, represented like this. So this is, now see, this is a natural join, it comes with theta join. In theta become equals, then it become equijoin. Equijoin. Okay. So theta equals, then become equijoin. So represented through the symbol. Represented through the symbol. Okay. So I will give a small example. So retrieve the employee names. Retrieve the employee names who works for IS department. Who works for IS department. Okay. So previous we had a table, right? We had a huge table of employee, because what are the queries I discuss? What are the queries I discuss? I comes with a company database as an example. Company database as an example, because based on that example I can go with well defining the entire DBMS, so that this make you to understand very easily. Understand very easily. Okay. So employee containing SSN, name, each, D number with D number. So employee, age, SSN with D number Because I'm going to give example for equijoin. I'm going to give example for an equijoin. So SSN, name, age, and day number. Okay. So this is a department table containing D number, D name, manager, SSN, manager, SSN. Okay. So then I have project table. So project table containing P number, P name, a location, D number. Then I have works on containing SSN, P number and hours. So employee, department, project, and works on. So my question is, I want to retrieve the employee names who work for IS department. That is my question. Right? My question, hope you understand my question, right? Hope you understand my question, that I want to retrieve the employee names work for ISC department. So my question is, condition is IS department, you require two tables, that is employee and department. So employee and department. So department with condition is department name, that is ISC, right? I want to retrieve the employee names working for IS department. So required name. So required condition is D name. So I want to utilize this D number primary key joins with a foreign key of employee department number to retrieve the employee name. You may ask, sir, why you are not joining SSN with manager SSN for department table? So when you talk about employee SSN with manager SSN, as I was discussed with the ER mapping table, we told employee managers department. In that relation, we taken all the attributes of department and taken the primary key of employee table. That makes what you call as department number, department name, manager SSN. So manager SSN represents manager information, not employee's information. It represents manager information, not employee information. When you think about employee information, you need to join department number with a D number of employee. Okay, this is the meaning you need to understand while talking about company database. Okay, so now, employee and department were required. The condition, as I told, I need to put D name is equal to ISC. Department. It's a table that required. Department is a table that required, right? So I'm retrieving D number as a attribute when you going for department name is equal to ISC. When you talk about department name is equal to ISC, so ISC is a department retrieving the employees of D number of ISC department, working to make join with the employee table D number and retrieving a name of a employees, right? So now, I'm retrieving name of the employees, by R1. So R1 contains D number joins with equi joins with employees. Okay, so R1 D number joins with E dot D number. That is R2. So now R2 is a relation. The final result R2 contains employee names who are working for ISC department. So question is very simple. I given retrieve the employee names working for IS department. So I used department table with D number, the D name. D name is specified with a condition at ISC. Retrieve D number for from R1. So join makes a relation with the R1. So then R1 joins with employee table. So R1 D number is equal to joins with the equi join works here. See, the equi join I'm working here. So when equi join represents this equi join, what equal symbol? Okay. So R1 containing relation of D number belong to IS department joins with employee D number. So retrieves the employee name with R2. Retrieves the employee name with R2. So R2 contain relation name of the employee names belong to ISC department. Okay. So this is one query that works well with the equi join. So then I may ask other question. Can you retrieve the employee names working on IoT project? Can you retrieve the employee name working on IoT project? So my question is very simple. I want to retrieve the employee names working for ISC department. Okay. So P name is ISC department. So P number, as I told, working, not managers, is working, right? So P name with P number. So employee works on project. So see the relationship. Employee works on project. P name represents IoT, comes with a P number. So P number joins, retrieve SSN. So SSN joins, retrieve the name working for project name called IoT. Okay, you required 3 tables, that is project, works on and employee. Project, works on and employees, and employee table that is required to do a query, that is employee names retrieved through for the given question, that is IoT project name. Given question, IoT project name. So first I will start with the conditions. Anyway, I will always start with the condition specified, because I will not go to directly joins with the tables and comes with the conditions at the end. So start with the writing a queries with the condition specified, and later part I am going to join all the tables what are the conditions specified required to successfully do the queries. Okay. So I am retrieving P number, P name, that is IoT, comes with the project table. Okay, next question. So next step of the particular query. Okay, so P number retrieved, so P name, IoT and project. So now I will I'll try to join this P number with the works on table, because I need to get a name. So to move to name, I required SSN goes with the SSN of employee. So now I am in P name condition, P number I retrieved. So now I'll join this P number with works on P number. Okay, and retrieve SSN. So here R1 joins with works on using R1 P number is equal to W dot E number, that is R2. So R2 done with retrieving SSN, that P number of a IoT matches with works on P number, So now I have SSN, so my job finally is to get a result through R3, so that is name, so name of the employees I am retrieving, R2 joins with employee table, tables, that is R2 SSN joins with E dot SSN, So here we made a beautiful query, right? For it I written a beautiful query. So it carries 5 marks. It's not easy, right? It carries 5 marks. So I'm getting for one question 5 marks. So that's what DBMS beautification makes. So want to score good marks? Write a query and get out of 4. If I write a theory, surely not get 5 out of 5, right? So this question is, as I told, you want to retrieve the employee names working for project name called IoT. So P name is equal to IoT, from project table I retrieved P number. So P number joins with works on P number, right? P on P number joins with W P number, that is retrieve SSN. Then this SSN goes, this employee SSN. So SSN R2 employee SSN joins and retrieve the employee name. That finally the R3 speaks about the employee names. Working for project name called IoT. So this is the beautification of equi-join. So you are required, whenever you write a query, you are required equi-join. Most of the queries are written based on equi-join. Okay. So this is what the natural join, theta join and equi-join comes about. Okay. So next we discuss about outer join, division and grouping. Okay. These three symbols makes relational algebra more stronger. This entire set of symbol make easy for us to write a query, make easy for us to write a query based on all these symbols for effective retrieval. It's very easy to write. So when I start, if you study one selection algebra, you can write n number of queries. You can write n number of queries using these symbols. Okay. Hope I made you to understand this natural join and theta join and AV join. Okay. Thank you so much.